Okay, so now we're going to talk about one more important property for logarithms that applies to any different base that we might have. It's a really valuable way of rewriting any logarithm so that we can actually kind of eliminate the base and talk about it only in terms of common base and natural base, that is base 10 and base e. So let me work through that and see if that can sort of explain what I mean by that. So this is called the change of base formula. Let's just start with a basic logarithmic expression, the one that we kind of began with at the beginning of the chapter. Suppose x is equal to some arbitrary logarithm with arbitrary base b and some base or some power y. Well, this all started when we were defining the inverse exponential function. So really, this is just an exponential function rewritten in log form. In other words, if I wanted to convert this back to exponential form, remember we have base power, said that wrong. We have base power exponent. Okay, so we can rewrite this as b, the base, to the x is the exponent, is equal to y being the power resulting from raising b to the x power. So we know y equals b to the x just from basic conversion between exponential and log forms. But watch what happens here. If we take the common log of both sides, so I just take both sides and I evaluate log 10 of each side. So I take log of b to the x power. Let me just rewrite this here, what I mean. So I'd have log of b to the x, I said that wrong. Log of b to the x power equals log y. Well, right here I could use the power rule, and that would give me x times log b equals log y. And it's just one simple step to solve for x here. And what I see is, log b here, that x is equal to log y divided by log b. And this might feel like a pretty random result, but if we look carefully at what we started with, I started with x is equal to one thing. I finished with x is equal to a different thing, which means that those two different things must be equal to each other, and this is what we mean when we talk about the change of base formula. If you have some logarithm, log base b of y, by all of this little algebra over here, we know that that would have to be equal to log y divided by log b. And this is what we call the change of base formula. Okay, so whether you follow that sort of verification and proof is not super consequential. It's great if you do. Ideally you would. Hopefully it's pretty simple. But really what's important here is that if I have a log with any base and any power, I can rewrite it in terms of common logs, right? This is really log base 10 in the top and the bottom. And what's nice is, really this is valuable to you guys as students, since all of your calculators, at least most of your calculators, won't really allow you to enter in these different bases here. You basically only have the common log function on your calculator and the natural log function on your calculator. So this allows you to rewrite any logarithm in terms of common logarithms so that you could actually evaluate that in your calculator, right? It's worth noting that I used common logs here, log base 10. We could have done all the exact same operations with the natural log base e. So I could also rewrite log base b of y as the natural log of y over the natural log of b. In fact, I could use any logarithm I want on the right side fraction. I could rewrite it as log base 6 of y over log base 6 of b. Just this isn't very helpful to me because my calculator doesn't have a log base 6 button. So I could use any base I want, but it's really only useful or valuable to us to use the common base, base 10, or the natural base, base e. But This allows me to express any logarithm of any base in a simple common log form with a simple fraction or a natural log form so that I could use my calculator. If nothing else, that's the nice value of this here. So if I said, for example, evaluate log base 3 of 7 with your calculator, again, most of your scientific calculators aren't really going to allow you to enter this subscript base 3 here. So in order to do that, I can use my change of base formula. Change of base formula says that log base 3 of 7 would be equal to log base 7. The power of 7 goes on top, and the base of 3 goes on the bottom, just like it's been happening in all the other cases, right? Power on top, base on bottom. And I could type this into my calculator. Let me just make an important emphasis here to make sure you close your numerator with parentheses so that your calculator evaluates the logarithm before it divides. Okay, the calculator might not do what you think it's doing, so make sure you divide log 7, take that value and divide it by log 3. So put parentheses around the numerator and the denominator. It's going to be most simple. If you type that into your calculator, you should get, hopefully, 1.77. We pull out my calculator here. This is kind of awkward because my calculator can enter those different bases in, but if we do it without those bases, if I just say log 7, and close those parentheses, and then divide by log 3, and I get 1.77. Again, my calculator displays these extra bases, and some of your scientific or graphing calculators might do that, but if you don't have that capacity, then you can just use regular common logs, log 10 on your calculator, and get those decimals and approximations to any logarithm at all. So now I've been asked, I think students have asked this before, how can I evaluate these logs with different bases than 10 and e? Well, this is how you can do it using the change of base formula. So that wraps up what we need to do for section 3 here in this chapter. For homework on this section, in your homework packet that you already have from chapter 8, on page 335, we'll be working through 37 through 57 odd, as well as page 339, numbers 33 through 51 odd, and 57. So when we talk in our live meeting, we'll talk about how we're going to go over homework questions as you have them. So you can send emails for questions. You can ask to set up live meetings with me through Teams if you want, and we can try to do just work through some questions there as well. But we'll talk about that more in our live meeting on Monday. So there we go. There's section 3. And enjoy.